Demystifying Dotnet Standard and Dotnet Core, or actually in the other way around, Dotnet Core and Dotnet Standard is the order I'm going to be talking to them in. There seems to be some level of confusion, not just in our space, but in the industry generally, about what all the .NET environments are these days. But it might be easy to think, well, wait a minute, isn't .NET just .NET? And that certainly a little while ago used to be the case. It was clear. .NET, we all know what that means, and it was very clear and well understood. It was .NET Framework. It was about websites, services, desktop applications, and pretty much Windows stuff. Okay, so it was a development environment for the Windows platform. But then along came things like Xamarin and Mono, and .NET started to spread its wings onto other platforms. Today we have .NET Core, which is kind of a cross-platform implementation for websites, servers, console apps, Windows, Linux, Mac OS, so it has some platform independence in there. And we'll talk a lot more about this in the future. And then there's the .NET Standard word. Well, what does that mean? .NET Standard is a base set of APIs that are common to all .NET environments. And it seems like certainly when you start to Google, what is .NET Standard or what is .NET Core, I frequently run across articles that are describing it completely wrong. And people have just kind of misunderstood what each of those things is. So I'm just going to try and spend a little while and clarify some of these things so that hopefully we have a basis of understanding that's correct moving forward into some of our newer technologies which are going to leverage these things and sit on top of these things, namely right now the Harmony Core framework. So .NET Framework we're all probably familiar with. Back in the beginning of .NET, introduced initially in the year 2000, was the .NET Framework. The .NET Framework is extremely, well, even back then was and obviously continued to grow, and now is an extensive, very powerful, very flexible framework that is available on the Windows platform only. Okay, and now I don't want this statement to be misunderstood, but compared to some alternate things that are available to you that you might wish to consider, the .NET Framework is kind of bloated and kind of slow in a lot of areas. Okay, there's a lot of stuff in there. You can do so much stuff with the classes that are available in the .NET Framework and its base class libraries and extensions and so on. But in some ways you pay for that capability and that feature set in terms of performance and the amount of memory it uses and how long things take. Okay, but don't get me wrong, I'm not trying to say .NET's dead. I'm not trying to say you all need to move off .NET. It's still a great solution for many workloads, existing apps, things that are just not available in .NET Core yet or may never be or whatever that is. Third-party libraries that are not available in other environments, then those are the sort of things that guide those choices. A few years ago, actually surprisingly very shortly after the .NET Framework itself was introduced, we started to see the first third-party implementations of that, and Mono has actually been around in its earliest form since 2001. Mono took .NET to the cross-platform environment. It provided a .NET common language runtime, a framework, and a C# compiler on alternate platforms. Most notably were Linux platforms, BSD, Mac OS, Solaris, and it was also available on Windows as well. So even since 2001, there have been efforts underway to enable .NET development in a wider scope than just Windows. Clearly, a lot of that came to a head, and people became very aware of that in 2011 and later timeframes when Xamarin came about and started to all of a sudden make fairly major impact in the industry in terms of allowing you to develop .NET-based applications and deploy them to platforms like Mac, like iOS, like Android, and later with common code bases and common UI and all that kind of stuff. So there's another .NET platform. For a while, we had this thing called portable class libraries that was really getting kind of popular. And what portable class libraries allowed you to do was deploy certain pieces of code cross-platform, as the name suggests. So you would be able to, in some cases, with limited success sometimes, take a piece of code and maybe run that piece of code or share that piece of code in a portable class library, perhaps across Windows Phone platforms back in the day, Linux, Android, iOS. It was really primarily focused on the devices, I guess. But the problem with portable class library was each of those devices had its own set of capabilities. The portable class library wasn't an ultimate specification that said this is what it can do. One device, an Android device portable class library had certain capabilities, and an iOS portable class library had others, and a Windows one had others, and a Windows 8 one had different ones to Windows 10 and so on. So what happened with the portable class library is the more platforms you said you wanted to support when you created the library, the less features you got, because it was essentially a lowest common denominator implementation. Then came along this thing called Dotnet Core. So Dotnet Core is a general purpose development platform that is maintained by Microsoft, but it is open source, okay, as is almost everything that comes out of Microsoft these days. It is maintained by Microsoft and the .NET community on GitHub. So it's open source, it's cross-platform, okay, so all of a sudden Microsoft now have an implementation of .NET that is cross-platform. It supports currently Windows, Linux, and macOS. And it can be used typically right now in the version that we're dealing with today, which is 2.1. It's typically used for device development, for libraries for devices, services, cloud-based stuff, embedded or IoT type scenarios. But in the future versions that are coming, there's going to be a whole bunch of extra stuff that you can do with .NET Core and entering into the desktop realm, and I'll touch on that a little bit later on. What .NET Core is really focused on in a big way is performance and scalability, okay? And you'll learn how that happens in subsequent slides. It's especially useful and targeted at services and microservices and little microservices running in containers and all of that kind of stuff. And it has a very significantly smaller footprint and typically much higher performance than the .NET framework itself. So if you were to implement a RESTful web service, for example, in .NET Framework versus .NET Core, and then monitor the performance of those things and do scaling testing and things like that, you would typically expect to see the .NET Core implementation of the code running an awful lot faster. The characteristics of .NET Core then, it's cross-platform. I already mentioned it runs on Windows, Linux, and macOS right now. It is open source. It's available to be ported to other platforms. Microsoft may port it to other platforms. Other organizations may port it to other platforms, even individuals. I could go out there and grab, well, I'm not suggesting I necessarily have the skills to start porting the framework around, but any of us could go out there, grab the source code for it, make whatever tweaks are needed, create a new runtime for some new platform, and go off and support that platform. It is very flexible in the way that you can deploy .NET Core. With the .NET framework, you essentially have to have the framework installed on the Windows machine in order to run the application. With .NET Core, that is unusual. That is still possible, but generally, .NET Core applications deploy the framework and any dependencies and so on with the application. So it's more like an application bundle, where that application bundle has everything it needs. It's got the .NET Core runtime in there, it's got all the dependencies in there, it's got the Synergy runtime in there, so it's totally standalone from other applications on the system. And that means that one .NET Core application might be running .NET Core 1.1, and another application might be running 2.1, and another one might be running version 3 beta, all on the same machine, because they all have their own frameworks and runtimes built into the application itself. The .NET Core framework can be installed side by side if you wish. There is a mechanism to do a user-specific install. There is also a mechanism to do a system-wide install if you choose to do so, but that, I think, it would be considered unusual. And it can also be deployed in Docker containers, the concept of running up microservices for, production use, or for whether it's for unit testing use or whatever. .NET Core revolves around the use of a lot of command line tools, and it's a stated goal or a stated position that all product scenarios can be exercised at the command line. So you do not have to use an IDE to do .NET Core development. Clearly there are some IDEs on Linux, for example, but you can do everything at the command line. You can create new projects, edit code, build things, run unit tests, start hosting applications, all at the command line if you wish. Or there is improving everyday support in Visual Studio. In older versions, the Visual Studio support in .NET Core was a little bit sketchy, shall we say. There's still a few challenges in there today, but it's getting pretty good at this point as well. So generally speaking, you're going to use one of the, probably Visual Studio in our world, because most of us have access to that tool. A lot of people in .NET Core also use just the Visual Studio Code Editor. Obviously, that's available on Linux and on Mac OS as well, and so on. .NET Core is compatible with .NET Framework and Xamarin and Mono through something called the .NET Standard, which we'll talk about in a little while. And again, just to re-emphasize, everything's open source and it is supported by Microsoft. Included with .NET Core, so what do you get when you install or when you create a .NET Core application or and it downloads its runtime and its library? Well, the answer is not very much. You get a really basic environment. You get primitive data types. You get a few more complex types like generic list and generic dictionary. You get an HTTP client. Interesting, that's quite a high-level class. Well, that probably says that Microsoft pretty much expects RESTful web services to be used from every application, so they're providing the HTTP client right there by default, and file stream, so you can do local basic file access and so on. And you get a few additional data types like data sets and DB sets to let you talk to data sources. And the runtime, of course. When you install .NET Core SDK, you also get language compilers. Out of the box, you'll get C#, Visual Basic, and F#. And you get an app hosting program called .NET.exe. And as you'll see when you start to do any .NET development, all of these command line tools that I mentioned earlier, they're all .NET something, .NET something, .NET new to create a project, .NET build, .NET test, .NET run. Okay, they're all there. So the .NET command is kind of a host for other commands that get plugged into it by tools and so on, and you get a certain number of them out of the box. So if the .NET Core framework is so small and there's hardly anything in it, how is it useful? And the answer to that question is all the cool stuff is on NuGet, in NuGet packages. So you start with a basic environment that has almost nothing in it, and then you start selectively picking the packages and the namespaces and the extensions that you want in your application. So clearly, you're not getting everything that Microsoft chose to put in the .NET framework that's there. You're getting specifically what you targeted and said what you need, and that's where a lot of the optimization and performance comes from, because the app is small and lean compared to .NET Framework applications. So that's really cool. It lets you choose exactly what you want and only what you want. Everything is open source pretty much. Less resources used, lighter and faster, but that's also one of the big problems with .NET Core, and certainly in the early days when you first start coding with it, it can be frustrating as heck just figuring out, well, what's out there? There's no user guide to NuGet.org, you just got to go to the website and start searching. It can be a little bit frustrating knowing what's available to you. And even if you know something's available to you, what's its package name? What's the latest version? Is the latest version stable? This is all open source stuff. Who knows who put it out there? Thankfully, Microsoft do a pretty good job of, you can visually see on this slide, .NET, 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 .NET. These packages are Microsoft packages that are considered part of the environment, okay, rather than being third-party things. So that gives you a level of confidence. Okay, so NuGet is both really cool and also one of the frustrating things about .NET Core in the early days. And that includes our stuff. Harmony Core, if you want to do Harmony Core development, you install a NuGet package. The Synergy runtime comes from NuGet. The Synergy compiler comes from NuGet. .NET Core workloads. Out of the box today, in old versions through 2.1, which is the current version, .NET Core includes support for a single application model, which is console applications. So if you just install the .NET Core SDK, you can do one thing essentially, which is create console apps. And then you start adding other frameworks on top of that through NuGet packages. So common package types and common workloads, ASP.NET Core has now become a pretty well-rounded, pretty comprehensive environment that's compatible largely to the .NET implementation of ASP.NET. Windows 10 UWP is a .NET Core environment. Xamarin Forms, for example, you might go off and add those kind of features. And Entity Framework Core. Jeff's going to talk about Entity Framework. And these are just some of the examples of additional typical workloads that you can create when creating .NET Core applications. But right now it is still largely about console apps. Now, console apps may host a service, so you might run the console app as a cron job on Unix, and that console app's running in the background all the time, hosting your RESTful web service, or it might be a command line tool. So console apps and some kind of web-based app, whether it's a web application or a web service, are the two primary workloads for .NET Core today. That's all about to change. Just to give you an idea of how fast things are moving, again, one of the frustrations in this world is things move really fast. And it's sometimes kind of hard to keep up with what's the latest version of what, and should I take it, and how well does it work? Have I tested with this new version of this package? .NET Core itself is moving really fast as well. It started with 1.0 in June 2016. So just a little over 2 years ago, this all started, and we're already on the 4th major release, so 2.1, 1.0, 1.20, and 2.1. But between each of these releases, of course, there was 1.01, 1.02, 1.03, 1.0, literally every few weeks. I guess there probably is an absolute cadence. I'm not sure exactly what that is. But those, 1 to 2 months it says down here. Okay, so literally this thing is getting updated and new features and bug fixes all the time. Okay, and right now we're heading off towards version 3, which version 3 I think was announced at Build earlier this year, and we're getting towards release date for that. .NET Core platforms and chips. So .NET Core is currently supported in the current version on the platforms listed on the left of the slide there. So from Windows to Mac OS to various Linux platforms and so on. It's supported on x64 chips on Windows, Linux, and Mac OS. It is supported x86 on Windows, not that that's particularly important for many people these days. It is supported on ARM on Linux. And Synergy is currently supported on the Windows platform, and we're very interested to speak to anybody who might want more than that. In fact, I'm going to try and point out a few times that I created an ideas entry a couple of weeks ago in the Community Ideas Forum saying, we now support .NET Core on Windows. Is anybody interested in having support, for example, on Linux? And I'd very much encourage you to start participating in that discussion if that's something you are interested in. Developing with .NET Core, I kind of already spoke to this. IDEs, Visual Studio support is pretty good these days. You can do .NET Core developments in Visual Studio Code. You can do .NET Core developments in Visual Studio for Mac, which is formerly the Xamarin Studio, I guess, rebranded. And with languages C#, VB, F#, and of course with Synergy.NET. And again, bear in mind, if you really need to, everything can be done at the command line. Deploying .NET Core apps, again, I already kind of spoke to this. I probably spoke to that earlier slide a little bit too much, but bear in mind that by default, when you publish a .NET Core app, and that's a .NET command to create a publish package, then by default it will package up the runtimes and all the dependencies and the libraries that application uses and publish it out to a folder for you. So you use .NET Publish to create those application bundles, and then typically you just do file system deployment. You can just zip the whole thing up and deploy it to another system and unzip it. Or if you prefer, then you can still continue to use tools like Install Shield, or probably more likely Wix or something like that these days, to deploy those files to some target system. In terms of hosting .NET Core apps, currently there are several ways that apps can be hosted. We have tested all but one of these successfully so far. So you can publish a .NET app, you can host a .NET application either in a console application. That's what we'll be doing with our Harmony Core services. It's a quick and easy way to do things. So we'll just be building a console application, and when that application runs, it starts up the web services in the background and hosts everything for us. If you prefer, in a production environment on Windows, you can use .NET Core to publish and host things inside of Windows services. You can also publish .NET Core web-based applications through IIS. So there is an IIS hosting package that you can install that gives IIS the ability to host .NET Core applications. You can also host .NET Core applications as an Azure App Service instance. Jeff will show you a demo of that happening later on. And we haven't tested yet, but in theory, there's no reason why all of this stuff shouldn't work inside Docker containers as well. So the current flavors of .NET, there's really three popular flavors of .NET these days. There is the .NET Framework, which is the full-fat Windows experience. That's where you're going to be if you're working in or living in WPF land or Windows Forms land or traditional ASP.NET land. And it has its own base class library with all of its capabilities, right? The .NET Core framework, if you're working in WPF or ASP.NET Core or any of those workloads we talked about earlier, you'll be working in the .NET Core environment with its core library, which is very small, but then plugging in lots and lots of NuGet packages to get the features that you want. And then, of course, there's the Xamarin platform with its iOS and OS X and Android support. And again, it has its own base class library. And all of those base class libraries, in some cases, have common features. In some cases, have identical features. In some cases, those features may differ slightly. but there's a lot of duplication going on there. So that's what .NET Core is, okay? It's a cut-down version of the .NET environment that is focused on platform independence, performance, scalability, those kind of things. So what is .NET Standard? Well, .NET Standard is an API that all .NET implementations must adhere to, okay? So it's a contract that says, if you want to be considered an implementation of .NET, you have to support all of these things, okay? So the advantages of .NET Standard is it really simplifies development because it contains a common core set of functionality that will work and is guaranteed to work across all specific implementations of .NET. Okay, so it really really achieves what PCLs kind of promised to and never really got there with. So it can really give you better portability, better code reuse, and easier management when you are dealing with cross-platform developments in the .NET world. So a .NET Standard class library is guaranteed to work on any implementation of .NET, be it framework, be it .NET Core, be it Xamarin, be it Mono. This stuff will work across all of those platforms. .NET Standard has very strict versioning rules. So .NET Standard is declared to be additive, and that means that the standard versions are logically concentric circles. So in terms of adding new features and making changes, a higher version of .NET Standard guarantees that it contains all APIs from the previous version, and there will be no breaking changes allowed between versions. So once you've started using a specific feature in .NET Standard, you can rely on the fact that that feature will always be there and will not change, okay? Might get extended with additional capabilities, but the core APIs that you're dealing with will not change. The .NET Standard environment is immutable, so once shipped, the versions are frozen. Again, there is no way they're going to go back and make a change to what is 1.0, what is 1.1. Once it's shipped, it's not going to change. And new APIs, the way that new APIs make it into the .NET Standard environment is typically they first get implemented in one of the other environments. So .NET Core might implement a new feature, for example. And then the .NET Standard board review new features that have been added to .NET Core and Mono and Xamarin and the framework since the last release of .NET Standard. And we'll make a decision, we're going to cherry pick, and this thing that .NET Core did, we're going to lift that and we're going to put it in the .NET Standard so it's going to be available to all the other platforms. So that's how new features get added to the .NET Standard environment. So .NET Standard versus portable class libraries. .NET Standard PCLs are still out there. Clearly a lot of you may have them and may be using them, but .NET Standard kind of supersedes what PCLs tried to do. So they improve on that experience by really providing a standard-based class library. You know, one of the problems with the previous environments was everything had its own base class library, and while there may have been a lot of similarity there, it was not guaranteed. So .NET Standard guarantees you a consistent set of APIs in the base class library that work across all of those .NET platforms. You do need to sometimes put some thought into what version of .NET Standard you decide to target. Clearly, the higher the version number that you select, the more APIs that are going to be available to you. But also, you need to pay a little bit of attention because if wide platform support is important to you, then some platforms may not yet have caught up and may not support the certain features that you're looking for. So the higher the version you go, the more features you get, but the less number of platforms support that feature at any point in time. And obviously, the platforms will catch up over time, hopefully. Microsoft have this whole page that this was a snippet from that kind of explains exactly what features are in what frameworks, on what platforms, and so on. So just be aware of that. It's not necessarily the case that you want to just jump straight into the highest version because you're limiting yourself and you've not got some of the APIs available or not got support for some of those APIs on some platforms that may be important to you. Synergy support for .NET Standard. We initially supported .NET Standard with project templates in the 10.3.3e release. That was, I guess, kind of considered experimental support. So you can create a .NET Standard class library. There's no concept of a .NET Standard application. There's no such thing. It's just a class library that's shared by other applications. So the application itself is a framework app or a .NET Core app or a Xamarin app or a Mono app, and .NET Standard is a library that app is using. So we officially support .NET Standard class libraries in the 10.3.3f release. We support them anywhere that Synergy PCLs are supported. And I guess the message here is use .NET Standard class libraries if you can over PCLs, because if they give you what you need, then you're getting more portability by using a .NET Standard class library as opposed to a portable class library, and you're going to get better performance. Synergy support for .NET Core, again, in the same release we supported in 10.3.3e, we had experimental support for .NET Core class libraries and .NET Core console applications. And again, that support has been formalized in 10.3.3f, that was released, a couple of weeks ago now. But we currently support deployment, again, only on the Windows platform. Now, not to say it doesn't work. I have a build of CodeGen that runs on .NET Core on Linux, and it runs just fine. Our Harmony Core sample environment, yesterday I put onto a Linux box and it's working just fine. But there are some areas of the runtime that we need to do a lot more testing in. So Roger's right in his concern. It's not something that we can just jump in there and say, yeah, sure, it runs, we're fine. We are looking at whether there is demand, really, to do that extra work. There is an amount of extra work that has to happen to possibly support this stuff on Linux. And bear in mind, if you're building RESTful web services, maybe you're interested in putting them up in the cloud at some point, and generally speaking, hosting stuff on Linux is generally quite a bit cheaper than hosting stuff on Windows. So this is not just about current Linux developers. It's about, would you like to host your services on fast, cheap Linux systems? So give it some thought. And again, talk to all of us, contribute to the idea that's out there in the Ideas Forum. In terms of synergy licensing with .NET Standard and .NET Core, .NET Standard produces class libraries only, so it's always going to be hosted in the context of some other language. .NET Core licenses, if Synergy is installed on the machine where the .NET code is running, then it will just consume regular Synergy runtime licenses. If there is no Synergy installation on the machine where a .NET Core application is deployed to, and remember, there doesn't have to be for the app to run, because chances are the runtime and everything is in the package. Okay, but it still needs to get a license from somewhere. So if there's no Synergy installation on the machine where the application runs, then you do have the opportunity now of setting an environment variable, Synergy license server, and pointing it to the IP address, or better, the DNS name of your license server, and it will go off and get licenses from that Windows license server. So choosing the right solution, .NET Core, clearly if you want to write a command line utility, or if you want to have a long-running process that's the equivalent of a service, for example, then .NET Core may well be a very good choice. Web applications and web services, ASP.NET Core and all of its surrounding tools and technologies really is a very good environment these days, and significantly faster than ASP.NET in the .NET framework. .NET Standard, if you are doing .NET development on multiple platforms, so maybe you're doing .NET Framework and .NET Core, maybe you're doing some Xamarin development, .NET Standard is the way to try and get that common code base across all of those platforms if the .NET Standard environment provides enough support for you to do so. And chances are it does. I'm not going to go into a huge amount of detail about .NET Core 3.0. The next release of .NET Core is going to be version 2.2, and that's targeted for the end, sometime before the end of this year. And that's really an incremental release there. From what I can find out, they're really focused on just improving the development experience and improving the tooling and things like that. So doesn't look like there's any major new features in .NET Core 2.2. It's about development tools. .NET Core 3.0, on the other hand, there's not really too much information about this around. I did see some references to Q1 2019. But that seems unusual, or it seems unlikely if 2.2 is Q4 18. So I'm thinking sometime later in the year, .NET Core 3.0. There's lots of information about this. It was announced and discussed widely at the Build conference earlier in the year, so if you want specific detail, go look at the videos from the Build conference. But what they're doing in .NET 3 primarily is adding desktop support into the .NET Core environment. So there will be support for both Windows Forms and WPF, on the Windows platform only, so you're not going to be running your WinForms apps or your WPF apps on Linux. Although Jeff tells me the other day there's I forget what it was called now, but there's a third-party effort that lets you do just that. And that's a want we've had for quite a few years. Why can't I run Linux desktop apps? There is also support for something called Zamel Islands. So Zamel Islands gives you a way of hosting UWP inside WinForms and WPF applications. So if you do have an extensive investment in WinForms or WPF and you want to get some of the latest and greatest feel, and WPF, well, WinForms was terrible at touch, WPF was fairly bad at touch. UWP is where touch support really all comes together, and if that's important to you, but you've got a WPF application, for example, then maybe you can start embedding bits of UWP inside of your existing apps. And Zamel Controls basically says they are making available the UWP browser and media controls for direct use within Windows Forms and WPF applications as well. So some new features coming to both of those platforms. There is a utility available to prepare for migration, so if you do have an existing WinForms or WPF application, I forget the exact name of the utility, but Google it, there's a utility out there that will tell you, yep, you're good to go, or you're using this API and that's not available in .NET Core at this point in time, and so on. So it looks at what you're using in your app and tells you whether you're in good shape or not. And I think it actually estimates, I think it looks at the roadmap as well and says, oh, this bit's scheduled for this time frame or something like that. Additional information, .NET documentation is a great place to start it. Hyperlinks off to all over the Microsoft website for information about .NET generally. So you start drilling in and say, I want .NET Framework, and then you got all that stuff, or .NET Core. And watch the .NET blog. Like I say, things are moving really fast in this world, and new features and new functionalities coming out all the time, and the blog is where things get announced initially.
Does the bundling of .NET Core into the app itself result in a significant increase in installer download size, or is .NET Core so small as to have no impact?
Yes and no. It depends what packages you use. It doesn't necessarily deploy the entire environment. It deploys the assemblies that you have used in your code. But yes, they can be a fairly significant size. I think, and we haven't done any analysis on what packages we are referencing versus using in our environment right now in Harmony Core, but I suspect we may have a few package references that are not required at this point, and that's, again, it's on my list of things to look at. But I think the Harmony, well, let's look. I think the Harmony Core environment right now, once published, see, inetpub, Harmony Core, there it is. Okay, this is going to be a bigger number. There we go. It's still not too bad, 119 megabytes. So that's the application, it's the .NET Core frameworks and runtimes, it's the Synergy runtimes, it's all the references we're using, it's the entity framework stuff, and everything. So that's not too bad. Okay.
Are you aware of any ports to Open Vms?
I am not aware of anything current. There was an effort to port Mono to Open VMS many years ago, but I don't believe it actually went anywhere. Anybody? Jeff, do you know of anything?
There's nothing for .NET Core on VMS currently. That's not to say that if someone was really motivated, they couldn't make that happen. But the main limiter would be the JIT compiler. Doesn't have any Itanium support anymore. That got dropped from the full framework a really long time ago. So what remains of that compiler is not particularly usable. So this might be a viable target on x64 for VMS when they get there, but until then, it's probably a pretty big effort.
Okay. We do, as you will see later, in Harmony Core, we do have a mechanism, however, for running Harmony Core web services and calling back into traditional Synergy backend systems, including OpenVMS. And in fact, that's one of the demos that Jeff will show you later today.
How do you handle multiple versions of the .NET Core framework when you have hundreds, if not thousands, of microservices? How do you issue patches?
If you're doing microservices the way everyone else does microservices, then you're probably putting those microservices inside Docker containers or some tiny containerized something. And if you're using that many Docker instances, you almost certainly need to use Chef or Puppet in order to control those Docker instances. So that's how. You'll have thousands of these things floating around, and you'll manage them with automation, and hopefully get the tires off quickly and drive away in 3 seconds.
Okay, thank you very much.